This video goes over an introduction to combining functions. So in our first example, we've got f at x and g at x, and the question that we're asking is what is f at x plus g at x? And so we get h at x when we do that, and we're going to add f at x plus g at x together. In order to produce the graph of that h at x, we do the principle of superposition, which is graphing the sum of the functions by adding the y coordinates at each point. So for f at x, we're just squaring the x coordinates, so we'd get 4, 1, 0, 1, 4. G at x is just 3. And then when we add those together, we get 7, 4, 3, 4, and 7. And then graphing those functions, we're going to add the y coordinates of each point and keep the x coordinate the same. So -2, 7, -1, 4, 0, 3, 1, 4, and then 4, 7, which is just a parabola that is opening upwards, which we can also recognize from the equation. The domain of our f at x function is all our possible x values, and so we just have all our real numbers. Our range is going to be from 0 to positive infinity, because this is our parabola. G at x is equal to 3, so our domain is still all the real numbers, but our range is actually only equal to the value of 3. And our domain here, we can see from this parabola, is that it's still all the real numbers, so minus infinity to infinity, but our range is only from 3 to infinity, which is kind of the combination of those two ranges. So let's take a look at another example here. We've got x squared and x this time. Now we're adding f at x and g at x. So we know that our function is going to be the sum of those two. And then we're going to find the y values of each individually and then add them together. So again, for f at x, we are squaring those values. So 4, 1, 0, 4. And then g at x is just equal to x. So we get -2, -1, 0, 1, and then 2. And then to find the y values of h at x, we're just going to add those two values together. So 2, 0, 0, 2, and then 6. Now we can plot them on. So I've got -2 and 2. I've got -1 and 0, 0 and 0, 1 and 1, and then 2 and 6. Now I know this is a parabola, and I know that it's going to go below the x-axis a little bit. For my range, I need to find where that lowest point is. That lowest point occurs at the vertex. That x value is going to be halfway in between those x-intercepts, which is at -0.5. Then I need to find the y value of the vertex by substituting in that value here. So I've got 1/2 squared minus 1/2 based on the question. 1/2 squared is going to be 1/4 minus 1/2, which is going to give me -1/4 as the y value here. I can put that on in red. So that vertex point is at -1/2 minus 1/4, which is going to allow me to fill in the characteristics below. So the domain of my function of f at x is all real numbers. G at x is also all real numbers. So my domain is the sum of those two sets, which is all real numbers. The range for my first one is going to be just my x squared function, which is from 0 to positive infinity. The range of my second function is -1/4 to positive infinity. When I add those two ranges together, the range of h at x is going to be 1/4 to infinity here. Well, I'm going to change this range. I was looking at my final answer. the range of this line, because g at x is just x, the range of that would be all real numbers. And then my new h at x is going to be the range of my final function. So let's do one more example graphically with a difference of functions. So I can also find h at x by subtracting those two values. My f at x values are squared, again, same as the other two examples. G at x is just equal to 4, so my y values are all the same. Now this time when I'm finding my h at x values, I am subtracting those numbers, and then I'm going to plot them on my grid. So I've got -2 and 0. I've got -1 and -3, 0 and -4, 1 and -3, and then 2 and 0, which is a parabola again. My domain of my original function is all of my x values. My domain for g at x is still all of my x values, which means that my domain for my composite function is all of my x values. My range for the first one is going to be, since I've just got x squared, so I'm still going to go from 0 to infinity. The range for my g at x value is actually just 4. So that means that the range for my composite function should be a collection of those two values, which is from -4 to infinity. And then we can also find a variety of values algebraically. So here I've got h at x is f at x plus g at x. And this is going to give me 2x squared plus 3x plus 4. When I evaluate h at -2, I'm just going to put in -2 wherever I see an x. And then I'm going to evaluate. So -2 squared is 4. This would be 8. Take away 6 plus 4, which would give me a value of 6. And then I can repeat the same thing for the function p at x, except I am subtracting those values. So 2x squared plus 3 minus 3x plus 1 is going to give me a new function of 2x squared minus 3x plus 2, which means that p at 5 is 2 times 5 squared minus 3 times 5 plus 2. And then I've got 5 squared is 25, so this is 50 minus 15 plus 2, which is going to be 50, 40, 35, 37, which is how I can evaluate the composition of those functions.